Okay, here we are on page 62. We're going to continue on with solving absolute value inequalities. So this may be the video that you need to listen to a couple times. I'm going to try to walk you through it, and then hopefully we'll have a chance to do some examples in class. So here's how this sorts out. You are going to isolate the absolute value. I don't know why I have this pen going here. Isolate the absolute value. Please. Let's see if I can get this going right. Right here, isolate the absolute value, and then sketch a graph of the situation. So in this first example, of course, the absolute value greater than 2 means that the point X is a distance greater than 2 units away from 0. So the graph looks like this. Here's -2. So all the points that are this way from -2, and here's +2, all the points that go this way, and I could go get a different pen color, that might help you. All of these make this inequality true. And this is an OR kind of graph. They are greater than 2, or they are less than -2. So again, we've got our land of Gore. Greater than is an OR statement. So G stands for greater than, OR statement following it. So the other option, of course, is a less than. And that means that the points that we're looking for are a distance less than 2 units away from 0 on the number line. To make this true, that's what needs to happen. So this number line looks like this. Our points have to be less than 2 units away from 0. Here's 0, here's 2, here's -2. The only points that satisfy that inequality are these guys right here. That is an AND type of situation. So that's a less than, and it's an AND. So for greater than absolute value inequalities, you have an OR situation, and you are actually setting up 2 separate inequalities to solve, where your variable is less than the negative value, this guy up here, less than the negative value, or the variable is greater than the positive value. And this is this picture right here. For less than, you have an AND situation, and you write it as one inequality with your variable in the middle. And we did this back in our compound inequalities, I think in 3B as well. So let's go down and work a couple of these. Here's one, our first one, we need to isolate the variable. That means get rid of the 2. So now we end up with the absolute value of x minus 1 less than or equal to 4. That's a less than situation. If it's a less than situation, it's an AND, land of Gore. This one is a less than. So we are going to simply take the x minus 1 out of the absolute value sign, and we're going to follow this rule right here. We're going to let it be less than the positive, less than or equal to, in this case, the positive value, which is 4. 4 is positive. And it's also going to be greater than or equal to the negative value. Am I not doing this right? Wait. Sorry. Erase. I got to isolate my x first. Okay. So let me go back over here. I need to add 1. So this was -4 here and +4 here. I've got to get the x alone. I was getting ahead of myself. And we have -3 less than or equal to x by himself less than or equal to 5. So we set it up correctly, x minus 1 less than or equal to the positive value, 4. and greater than or equal to the negative value, -4. Then in order to actually solve it, we've got to get the variable alone, and this ends up being our answer. And if we were to graph it, because it says solve and graph, we take our positive value, we take our negative value, and it's all the points in between that make this a true statement. These are the only points that make this a true statement. Let's look at the next one. It happens to be a greater than. So it is going to be an or situation. And watch carefully to what I do. First of all, I'm isolating the absolute value. This is a no-brainer. Absolute value of 2x plus 3 greater than 5. That's all well and good. Now to set up what we need to solve, I need to go back up here to my rule, and it says, where is it? Right here. We're writing two different inequalities. The variable is less than the negative, or the variable is greater than the positive value. So here's what it looks like. 2x plus 3 is greater than the positive value, 5, and then the second inequality is 2x plus 3 less than the negative value, which is -5. So I have flipped the sign, and I've also taken the opposite of +5. Now, of course, we just solve these normally, and we get 2x greater than 2 and x greater than 1. For that side of it, 2x less than -8, divide by +2, so we don't have to flip the inequality symbol, x less than -4. And if we were to graph that, we take our two target points, which are -4 and 1, go get another color, and we are doing the OR type graph where they're going in opposite directions, and any of the points in red will make our statement true. So this was an example of solving absolute value inequalities with the less than inequality symbol and the greater than inequality symbol. And we'll do a couple more of these, but this will be it for this video. Thanks for watching.